Welcome everyone to another lecture of Industrial and Power Electronics. So the topic we are covering so far is the DC to DC converter. In our previous two classes, we have seen various aspects of DC to DC converter, what this converter do, how this converter works. So today we will try a new type of converter which is known as chuck converter. Okay. Now, everyone seeing my screen and hearing my voice clearly?
जी सर.
Okay, thank you. So, for this chuck converter, what does that mean? How this works? We will know. Okay, the final expression might seem similar from the previous cases, but this is a new type of converter. The DC to DC converter is suitable for only low frequency switching, not for high frequency switching. Low frequency switching means that the frequency is not very fast. Okay, frequency is not very fast enough. The switching is not very fast enough. The switching is very slower than the other buck boost converter. Okay, so this is applicable for the low frequency switching, which is very important line. Now, the circuit of this converter is here. If I say so, that you have to remember the circuit connection because it is very important. Okay, though we are now in online class and open book exams are very common now, but I will tell you to remember the circuit connection because it is very important. Now here we can see that in this circuit there is an inductor here, there is an inductor here, there is a new capacitor here. We didn't see any capacitor for the previous three converters. It is the DC input voltage. It is our diode. Here is our filter C plus load. That means there is a capacitor and resistance load. The capacitor we used earlier not for the circuitry connection but for the filter connection. Now, as there are two inductors, so calculation will be twice. Okay, as there are two inductors. One is for L1. Okay, for L1. Okay, so here we can see that the when switch is on, the inductor L1 is energized. When switch is on, inductor L1 is energized. So, okay, so for L1, we can see switch is on. So the loop will be in this region. Okay, so by putting the KVL here, we can see the current is entering in the minus direction V in. It is going in the plus direction here. So plus VL1 equals to 0. So it will be VL1 here. এখানে হলো VL1 হবে. There is some typo here. So here will be VL1 equals to V in. Now, when switch is off for L1, when switch is off for L1, switched off L1 এর জন্য, that means that the circuit will be no longer like this. The circuit will be like this. যে দেখেন switch off লেখা আছে. The circuit will be in these two parts. I'm going from here, coming down here and completing the circuit. Okay, this will be my direction. So as this is my direction, if I put a loop here, then it will be how it will be something like this. এই যে দেখেন এখানে কিন্তু switch off for L1. I'm seeing this for switch off for L1. So it will be go in minus V1 plus VL1 plus VC equals to 0. So it is energizing my capacitor. It is energizing my capacitor. So I have concluded my remarks for two cases. Whenever switch is on for L1, whenever switch is off for L1. So we can see when switch is off for L1, the capacitor VC has been energized. Okay, it has been energized. I hope it is clear. If I summary so far, in this case there are two conductors. One is L1 and one is L2. So there will be two cases for L1 and for L2. So far, I have discovered the cases when switch is on and switch is off for L1. Now I will try to find the cases for L2. very carefully watch. You can see that the for L2, the for L2, whenever switch is on, the circuit will be something like this. Okay, whenever switch is on, the circuit will be something like this, or you can draw the circuit like this. It won't matter. So when switch is on for L2, how the connection will be? The connection will be, if you go down here, it will plus Vc plus VL2 plus V naught equals to 0. Plus Vc plus VL2 plus V naught equals to 0. ওকে, সো এই হলো আমার ব্যাপারটা, ঠিক আছে? এই হলো আমার ব্যাপারটা যে প্লাস ভিসি প্লাস ভিএল টু প্লাস ভি নট ইকুয়ালস টু 0. So I'm getting the VL2 because why there is a supply of connections are because the input is detached. Although the input is detached, because my VC has been energized, that capacitor has been energized when switch is off for L1, and that capacitor is giving me energy for switching on in L2 case. Okay, that capacitor is giving me energy. Okay, so for L2, this is my connection. The capacitor is acting as a source in this case. So this is switch on for L2. If switch is off for L2, then what will be the connection? You can very clearly say switch is off, so there will be no this part. So the capacitor started to de-energize. We know when switch is on, capacitor energizes. When switch is off, capacitor de-energizes. We know it very, very well. So in this case, when switch is off, how it will be? It will be VL2 plus V naught. When switch is off, it will be VL2 plus V naught. You can rotate the volt like this or like this. You can rotate the loop in the clockwise direction, in the anti-clockwise direction or the clockwise direction. Both will give you the same result. So suppose I'm rotating it in the clockwise direction, then it will be plus VL2 plus V naught equals to 0. That is what they've written here. So wherever you are watching the recording again, I will suggest you to keep an exercise book or a sheet in front of you with a pen, and you try to solve the equations by writing them, because hearing them is not enough and it will not make yourself clear to some extent. Okay, so writing is very imperative, because you are just listening to the lecture will not give you a clear conception. Writing along with the lecture is very, very important, and there is absolutely no alternative to it. So far we have, in this chuck converter, we has অনেক chuck converter বলে আছে, যাই হোক. So far this in chuck converter, we have seen that there are two inductors, L1, L2. We have seen cases for switch on and switch off. So if I say that there are four cases: when switch is on the input side, when switch is on the output side, when switch is off on the input side, when switch is off in the output side. Okay, so there are almost four cases for this different L1, for these different L1s. সবাই আমার ভয়েস ক্লিয়ারলি শুনতে পাচ্ছেন তো না? হ্যাঁ
जी
এভরিওয়ান,
सर।
ওকে, থ্যাংক ইউ। Now I've said that for DC to DC converter, the calculation is one dimensional, because there are same procedures over and over again. When switch is on, inductor energizes. When switch is off, and inductor de-energizes. Then we take the voltage over L1 over the cycle. The same things we have done in the buck converter, in the boost converter, in the buck boost converter, and for the converter to reading today. We're reading today. Over the cycle L1, we see it is going from 0 to t VL1 dt. We know that it is parted with two sections. One is 0 to t1, one is 0, one is t1 to t. So when 0, we are doing this calculation for L1. We are doing this calculation for L1, not L2. So you have to put the value VL1. Here it will be VL1, and this VL1. Okay. So here I am putting the V input voltage because we can see VL1 is Vn, and here we will put Vn minus Vc. Okay, Vn minus Vc. So by calculating, I hope the calculation is clear now. If it is not clear, please see the previous two lectures. They're important. So T on into Vn, Vn minus Vc into T minus T on. So by the means of the calculation, we'll find something like this. What they do, they have taken the common Vc, then it becomes T minus T on, because they have taken a minus here. So if I put the direction in the right hand side, then it will plus Vc into T minus T on, then Vc by Vn, T minus T on, Vc by Vn, T minus T1. We know that we will divide the up part, the numerator part and denominator part by t, then it will becomes 1, it will become 1, it will become t on minus t. T on minus t we know is duty cycle. As we have done this calculation numerous times, that is why I've written it here directly. Okay, I hope whenever you are doing the calculation, you will understand that what we have done here, because this calculation we have done in the previous two classes. The t, we divide the t in the upper side and in the lower side as well. So Vc becomes Vc equals to 1 minus 1 minus d into Vn. Okay, so sir, we didn't get the output current. Yes, we didn't get the output current yet, but we eventually will get the output current. So there is absolutely no need to worry. We actually get the capacitor voltage here for the L1. Now, as we get the VC part, we need to get the IC part. Okay, so current, again, I have written here that IC is a part of IN when the switch is off. Though when the switch is on, a current through the capacitor still flows through L2 and load, but it does not come from Vin. Remember, IC is a part of IN when the switch is off. When switch is off, there is a part in IC. But you will say that, sir, when switch is on, there is a current here, but that current is not coming from the Vin. That current is coming from the VL2 and VC. Okay, so the current IC, whenever we're taking the L1, consideration in L1, when taking consideration of L1, the current going through VC is only applicable when the switch is off. Okay, when switch is off. So that is what they have written here, that the current IC, এটা কই গেল? আচ্ছা, হ্যাঁ, এই যে। So IC is a part of it when the switch is off, though when the switch is on, a current through capacitor still flows through L2 and load, but it does not come from Vin. So IC by IN will be what? T minus T1 by T. T minus T1 is the time that switch is off. Okay, remember? যদি মনে না থাকে, সবকিছু নতুন নতুন লাগে, তার মানে আপনি আগের লেকচার গুলো কিছুই দেখেন নাই। আগের লেকচার গুলো দেখে এটা দেখতে বসেন। So IC divided by IN equals to T minus T1 by T. So by the means of the calculation, I'm getting 1 minus D. So IC equals to 1 minus D into IN. But if you watch the lectures carefully, you will see that this expression is kind of the reciprocal of this IC. Okay, this VC is kind of the reciprocal of the IC. So expressions are kind of reciprocal. Now we take the voltage over L2. So 0 to T, VL2 dt equals to 0. And we replace our VL2 with these two voltages. We replace our VL2. We have VL2. Here is one of the VL2. Here is one of the VL2. This VL2 is for the when switch is on. This VL2 is for the when switch is off. I've described this, how this comes. So I'm not going there again. So replacing my VL2 here, replacing my VL2 here, then proceeding the same integration here, the same integration here. Why here is T minus T on all on a sudden? I have described it many times in the previous two lectures. I hope you will see, you saw them. If you didn't, you should. So by the means of the calculation, we can see that the output voltage is related with the capacitor voltage. But remember, our target for DC to DC converter is to relate our output voltage with the input voltage. So we can see that here my output voltage is related to VC, is related to the capacitor voltage. Now what we do, sir? We saw in the earlier case that there is a relation between the capacitor voltage and input voltage. So now what we have to do, we have to make 2 plus 2 equals to 4. দুয়ে 4 বানাইতে হবে আমাদের। কি করব আমরা? What we'll do, we will replace this VC part with this part. Okay, then there will be the expression we desire. V naught equals to minus D, that VC is replaced here. So V naught equals to minus D divided by 1 minus D into Vn. Also, we can find the current here also, as I naught does not come from IC. When the switch is off, IC is equals to minus T1 by T into I naught. Okay, the direction of IC and I naught are opposite. You can see the I naught does not come from IC when switch is off. Okay, I am now trying to relate the current IC and current I naught. So you can see that the current for L2 purpose, the current IC comes when the switch is off, and when the switch is on, there is no current here. When the switch is on, VL2, and when the switch is on, when switch is off, there is no current coming from the VC. So the current IC is only applicable when switch is on. That is what they have written here. The I naught does not come from IC when switch is off. Only switch is on. When switch is on, the current comes from. So IC is equals to minus T on divided by T into I naught. The direction of IC and I naught are opposite. So I naught equals to minus 1 by D into IC. And again, that IC we get in the previous section, the IC we are getting here will be replaced here, and we get the I naught value here. So I naught equals to 1 minus D divided by D into IN. Both buck boost converter and chuck converter have almost same and identical expression. Only the matter of concern is when we use what? Sometimes with the frequency, the switching frequency, if frequency high and frequency low, we will use according to that buck boost or chuck converter. So this is the ending of the chuck converter. The SEPIC converter we will not go through in our syllabus. The SEPIC converter is not needed. The last converter, the SEPIC converter, I am again saying the SEPIC converter you can leave out. Okay. We will not go to the SEPIC converter. The last converter for our DC to DC converter lecture is the zeta converter. By seeing that zeta converter, it will be the end of the expressions. Then we will try to find the inductor expression. Okay. So for zeta converter, we can see that there is inductor L1, there is inductor L2, there is a capacitor, there is a diode. So connection is, somewhat extreme because there are two inductors, but remembering the connection is very important. For the conventional engineering exams, the common phenomena was to draw a certain converter like buck boost that come in the exam. But now it's no longer the convention system. So proceeding for zeta converters, when switch is on, when switch is on for L1, when switch is on for L1, so we can see that the circuit will be something like this because switch is on. The inductor is energizing. Okay, so as inductor is energizing, the circuit will be minus V in plus VL1 equals to 0. So VL1 equals to V in. সবাই কি আমার ভয়েসটা ক্লিয়ারলি শুনতে পাচ্ছেন তো?
জি স্যার, শোনা যায়।
আচ্ছা, ঠিক আছে, thank you. So whenever switch is on from 0 to T on, the inductor L1 will be charged from 0 to T on. So minus Vn plus VL1 equals to 0, VL1 equals to Vn. Now, when switch is off for L1, the circuit will be like this. You can actually, the direction have to be like this, can't be like this. It has to be in the counterclockwise direction. Okay, counterclockwise direction when switch is off for L1. So the voltage will be, if I don't go in the bottom, you can also understand it will be plus VL1 plus VC equals to 0. You can see that when switch is off from T on to T, the inductor will energize capacity C. So VL1 plus VC equals to 0, VL1 equals to minus VC. Now comes for the L2 connection. As we can see that our inductor is energized, sorry, our capacitor has been energized. So for L2 connection, when switch is on, okay, when switch is on for L2 connection, what will happen? Switch is on kintu. So for the L2 connection, that the voltage will go like this, like this, like this, like this, and দেখেন একদম পুরাটা, the whole circuit will be now inside it for L2 when switch is on. Again, if VC now acting as a source, so current is coming out of it. So by KVL, we can see that it will be minus VC plus VL2 plus V naught and minus Vin equals to 0. As these all these converter connections are operating simultaneously. Not like that the some time that T on is on, T on the switch is off. It is working simultaneously. So the you have to think dynamically to understand the zeta converters, and also for the previous one. So you can see that the connection is something like this, and it will be minus Vn minus Vc plus VL2 plus V naught equals to 0. That is what they have written here. And for VL2 equals to Vn plus Vc minus V naught. Okay. Filter C drives the load. If energy of the filter decreases, the current from L2 energizes it. Okay. That means that whenever the capacitor voltage is decreasing, the another energizing source VL2 then supplies. Okay. Suppose one of your friend is tired, you are carrying on the task because you are still fresh enough. Now where we will try to find the switch off condition for L2. In order to find the switch off condition for L2, we can see that how the connection will be. The connection will be something like this, because the L2 is working as a source. So plus VL2 plus V naught equals to 0. You can see here that the VL2 plus V naught is equals to 0. Okay, this is switch off for L. There are dynamically 4 cases are going on. So it might seem difficult, but it is actually not that difficult. Just step by step, follow the process I'm showing you step by step. Then it will be easier. Just remember the directions, then it will be absolutely fine. Now we have in our bag the two of the connection. One is VL1, one is VL2, and we know both of these voltage expressions for switch on and switch off. So our task is now somewhat again simple and same. Now over the cycle, that same damn thing, over the cycle 0 to T, VL1 dt. Then we put the VL1 voltage when switch is on. We put the VL1 voltage when switch is off. That same thing again and again and again. So we get the expression VC here. In the L2, we'll get the expression V naught. Same finished again the VL2. We're replacing VL2 when switch is on. We're replacing VL2 when switch is off. Same thing again and again. Then we are taking the integration from 0 to T on to T, and we get the V naught. If we see what I've done here, I have given the voltage VC, directly here. So it is up to you. In this expression, I have replaced this VC here, Vn into d by 1 minus d, and I've taken the V naught in the right hand direction. So V naught has been cut out because this will be V naught minus V naught into t. This minus V naught into t going to the right hand direction will be positive, so it's gone, and there is only okay. There is even V naught by d because the d is in the dividing condition. Okay. Now this Vn plus Vn into t by 1 minus d equals to V naught divided by t. So by calculation, by means of calculation, I am getting V naught equals to d divided by 1 minus d into V in. V naught equals to divided by 1 minus d into V in. You get the algebraic calculation, I hope, easily. and get this value. Okay, do the algebraic equation by yourself. I hope you are mature enough to do it. So today we covered two of the very important converters. One is Chuck converter, one is Zeta converter. So for these two converters, the tricky part was that there were two inductors involved in both of the cases. So we have to think dynamically for these two inductors, and I hope things are clear. Now from the PDF, what we'll do, uh, there is a topic called continuous conduction mode. It is CCM is the process in which the current through the inductor is never zero, because it never would zero, it never will be zeros. Okay, that is called the continuous conduction mode. CCM, in short, this is called CCM. CCM is the process in which the current through the inductor is never ever zero. Now we will see a topic, determination of L minimum for which current through that inductor is never zero. Determine the determination of L minimum for which current through that inductor is never zero. In the previous topic, we have seen that the CCM is the process in which the current through the inductor is never zero. Okay, the expressions we have derived is for the CCM condition. Now we will end our lecture by seeing this topic. Determination of L minimum for which current through that inductor is never zero. How this happens? Now you can see that for buck converter, if we go একদম শুরুতে, ঠিক আছে, in the beginning, we go for the buck converter. Remember the buck converter? So in the buck converter, we have seen the expression of current when switch is on, when switch is off. Expression of current. And this expression of current is for IL. This expression is for IL. So when switch is on, IL is equals to Vn minus V naught, because again, the expression of where is it? The expression of IL. Okay, the expression of IL was important. Okay, the like 1 by L VL dt. Okay, this was our expression for current. Now we want to find this inductor value. We want to find this inductor value L in order to always a current flowing through the circuit. A current flowing through the circuit. We want to find the inductor value L. So that always there is a current flowing in the circuit. So please, you guys remember these two expressions. IL equals to Vn minus V naught by L. IL equals to minus V naught by L. This is for switching on condition. This is for switch off condition. Okay, because this is VL1 for switch on. This is VL. Obviously, there is no VL1 because there was only one inductor. This is VL for switch on. This is VL for switch off. You will see that the VL is replaced in those two. So now, this expression I am using here. This is the expression of inductor current for buck converter. So we can see when switch is on, Vn minus V naught by L, when switch is off, minus V naught by L. So this is the expression of current. So we know that IL equals to 1 by L VL dt, as the voltage is constant over the cycle. So we take out the voltage VL by L dt. Now for rising slope, when switch is on, we know this is the expression. For falling slope, this was the expression. Okay, for the expression VL1. Now we will find the delta IL. Okay, what will be the delta IL? Okay, the change in voltage. What will be the delta IL? Okay, delta IL will be V naught by L T minus T on. V naught by L, T minus T on. Okay, we have found the delta IL. Okay, this delta IL. This delta IL will be V naught by L, T minus T on. Switching should be done in such frequency that the filter C does not lose charge. আচ্ছা এগুলো আমি পরে আসতেছি. So what is the value of IL max and IL minimum? Okay, IL max and IL minimum. If you here see that this threshold value is IL. So IL max equals to IL plus delta IL by 2. এই যে দেখেন এইখানে যে পোর্শনটা plus delta IL by 2. And IL minimum is IL minus delta L by 2. This is the minimum current here. So for CCM, we always know that the IL minimum current has to be greater than 0. There is always has to be some amount of current. So IL minimum greater than equals to 0. So IL minimum is value here. You can see IL minus half of delta IL. So half of delta IL, then we can see that the half of delta IL, we can replace it V naught by L. এখানে দেখেন delta IL, I found the delta IL. V naught by L into 1 minus D into T greater than equal 0. By this expression, we can see that the I naught V equals to IR. So I equals to V by R. I naught is replaced by V naught by R greater than half into V naught by L into 1 minus D into T. By the simple algebra, you will find that L will be greater than 1 minus D divided by 2F into R. Okay, F follow is that this T has been replaced by 1 by F. So L minimum. So L has to be greater than this. So minimum value of L is equals to 1 minus D into R divided by 2F. So this is the expression of L minimum for buck converter. Okay, for buck converter, this L minimum is the minimum inductor that is required for CCM. That means continuous current mode. Okay, this is very important, and this expression is very important, and you need to remember this expression for the minimum value of the inductor. So thank you everyone. We'll proceed to the boost and the other converters inductor value in the next class. Thank you everyone. Have a good day.